Okay, here's section 2.5. In section 2.4, you were introduced to finding the inverse of a matrix and then solving a system of equations using the inverse method. We concentrated by solving 2x2 systems. In this section, we learn a different way to find the inverse of a matrix and then solving 3x3 systems. So the method that you learn for finding the inverse in the previous section does not work for a 3x3. What I'm going to show you today works for a 2x2, a 3x3, and so on. And in some ways, I think it's just easier. Okay, I'm going to show you the method of finding the inverse, but I'm going to start with a 2x2. So what I'll do first is I'm simply going to take, I've got this matrix 2, 6, 3, 4. So I'm going to copy those numbers over here. And then to those, I'm going to add this. So I went from a 2x2 matrix to a 2x4 matrix. And the last half, if you look at that, looks familiar. You see your ones on the diagonal and your zeros everywhere else. That's the identity. So all you did was add the identity there. Now, think Gaussian elimination. If we're using Gaussian, the first thing you want to do is get a 1 here. So we're going to take 1/2, row 1. So half of 2 is 1. I'll circle that. That's my pivot. Half of 6 is 3. Half of 1 is a half. And half of 0 is 0. Bottom row stays the same. Okay, again, thinking Gaussian elimination. I got the 1. Now what? We want to get a 0 where the 3 is. So we use where the pivot is, that 1. We're going to multiply by the opposite of that number. So the opposite of 3 is -3. So I'm going to take -3 times row 1. I'm going to add that to row 2. So the top row stays the same. So the bottom row, I'm going to multiply -3 times 1 is -3, plus +3 is 0. -3 times 3 is -9. -9 plus 4 is -5. -3 times a half is -3 halves, plus 0 is -3 halves. And -3 times 0 is 0, plus 1 is 1. So just like Gaussian elimination, the first column is done. I got a 1 and a 0 right there. Now what? I got a 1, I got a 0. I want to get a 1 where the -5 is. So I'm going to take -1/5, because that's the reciprocal of that number, times row 2. Row 1 is going to stay the same. Okay, -1/5 times 1 is 0, plus that 0 is 0. We knew once you get the 1s and 0s, they don't change. Oh, I'm sorry. It's just -1/5 times 0 is 0. -1/5 times -5 is 1. That becomes my new pivot. -1/5 times -3 halves. So the negatives drop out. 1 on top here times 3 there is 3. And 5 times 2 on the bottom is 10. So I got 3 over 10. And then -1/5 times 1 is -1/5. So at this point, I got the 1, I got a 0, I got a 1. I got to get a 0 up here. The bottom row is done, so I'm just going to copy it right away. To get a 0 here, you're going to multiply by the opposite. The opposite of 3 is -3, so it's -3 times the pivot's in row 2, and I'm going to add it to row 1. So -3 times 0 is 0, plus 1 is 1. Negative 3 times 1 is negative 3, plus positive 3 is 0. Now it gets a little tricky. Negative 3 times this. I'm going to write this off to the side. Negative 3 times 3/10 plus the number above it is 1/2. So it becomes negative 9/10. To add, you got to have a common denominator, so let's say 10. 5 over 10. 5 over 10 is the same thing as 1/2. So negative 9 plus 5 is negative 4 over 10. In lowest terms, that's negative 2/5. That goes over here. Okay, and then I've got to multiply negative 3 times negative 1/5. So the negatives drop out. That's 3 over 5 plus 0 is 3 over 5. Notice what happened. When we start up in here, see the identity there on the right? And at the bottom, the identity is now over on the left. Up here, this is matrix A. And down here on the right, what do you think that is? That's the inverse. So the inverse of the matrix that I started with is negative 2/5, 3/5, 3/10, and negative 1/5. So whatever you had on the right, that's what the inverse ends up being. Now, when we did this in the other method, remember how to find, first thing we did was found capital D. If you go back up here, that would have been 8 minus 18. 8 minus 18 is negative 10. Look down here at these fractions. See how 10, I could write that as 3 over 10, negative 2 over 10, 6 over 10, negative 4 over 10. So you still get that letter D to be 10. Okay. So that's what it looks like with a 2 by 2. Okay, let's go to a 3 by 3. I'm going to switch my utensils here. Let's try this one. Okay, so in this problem, you'll notice I got 3 by 3. I want to find the inverse of that. I'm going to use the same relationship I just had. So I'm going to start out, I've got 2, 1, 1, 3, 2, 1, 2, 1, 2. And then I'm going to put the identities, but the identity on this one is going to be 1, 0, 0, 0, 1, 0, 0, 0, 1. Since this is had 3 rows, then my identity is going to be a 3 by 3. But you'll notice over here I still got the 1s on the diagonal and 0s everywhere else. Okay, let's see if I can do this without running out of room. Okay, so the first step, we want to get a 1 where the 2 is. We're going to take 1/2 times row 1. Half of 2 is 1. That's going to be my pivot. I'll circle it. Half of 1 is a half. Half of 1 is a half. Half of 1 is a half. Half of 0 is 0, and half of 0 is 0. Second row stays the same. All I'm doing is copying those numbers. Third row stays the same. Okay, I got a 1, now I want 2 zeros. Top row is going to stay the same. Now you're going to get bored copying these numbers, and you're going to say, there's got to be a better way. Well, you got to remember, in a matrix, and we're doing Gaussian, you're getting rid of the x's, you're getting rid of the plus signs, you're getting rid of the equals. So those are things you don't have to copy down anymore. this would have been 1x plus 1 half y plus 1 half z, and we don't worry about those. Okay, to get a 0 here, we're going to multiply the top by -3. So that's -3 times row 1 plus row 2. -3 times 1 is -3 plus +3 is 0. -3 times 1 half, that's -3 halves. 2 is 4 halves, so we get -3 halves and 4 halves is 1 half. -3 times 1 half is -3 halves, plus 1. Think of that as 2 over 2, so I got -3 over 2, and 2 over 2 is -1 half. -3 times a half is -3 halves, plus 0 is -3 halves. -3 times 0 is 0, plus 1 is 1, and then 0 and 0 is 0. Now, if you have trouble following along, I try to keep this lecture part going, but if you're having trouble seeing where I got those numbers, redo the video, go off to the side, recalculate them yourself. You do it, and hopefully it'll make sense. Okay, in the last row, I'm going to multiply by -2 and add, so it's -2 times row 1 plus, now I'm going to add it to row 3. -2 times 1 is -2 plus +2 is 0. Notice how the first column is going to be done. -2 times a half is -1. -1 and +1 is 0. It's kind of nice. That's going to save me a step here in a minute. -2 times a half is -1 plus 2 is 1. That's going to save me a step. -2 times 1 half is -1 plus 0 is -1. -2 times 0 is 0 plus 0 is 0. -2 times 0 is 0 plus 1 is 1. First row or first column is done. Now we want to get a 1 right here. Top row is going to stay the same. I know this is tedious, just copying your numbers, especially when you got fractions. There's the first row. In the second row, I'm going to multiply by 2. 2 times row 2. 2 times 0 is 0. 2 times 1 half is 1. That's my new pivot. 2 times -1 half is -1. 2 times -3 over 2 is -3. 2 times 1 is 2, and 2 times 0 is 0. And the third row stays the same. So my first column's done, and when I look at the second column, I got a 1. I've already got a 0 here. That saves me a step. I got to get a 0 here. So I'm going to take -1 half times row 2, add it to row 1. -1 half times 0 is 0, plus 1 is 1. -1 half times 1 is -1 half, plus +1 half is 0. -1 half times -1 is +1 half. +1 half and +1 half is 1. -1 half times -3 is 3 over 2. Plus 1 over 2 is 4 over 2, and 4 over 2 is 2. -1 half 2 is -1, plus 0 is -1. -1 half times 0 is 0, plus 0 is 0. Row 2 stays the same. Row 3 stays the same. It's that same principle. You get a 1, you get 2 zeros, you get a 1, 2 zeros. So here I got the 2 zeros, but I already had that one to begin with. So the first column's done, the second column's done. And when you look at the third column, I would get a 1 here. It's already done, so I've only got one more step. I got to get 2 zeros. And we know the bottom's done. I'm going to put those numbers in here. Sometimes that helps with your spacing. Okay, on the top row, I want a 0. So I got to take -1 times row 3. I'll just write that as -row 3 plus row 1. So 0 and 1 is 1. 0 and 0 is 0. So they're not going to change. Negative 1 and positive 1 is 0. I got to take negative 1 times negative 1, that's 1. 1 plus 2 is going to be 3. Negative 1 times 0 is 0, plus negative 1 is negative 1. And negative 1 times 1 is negative 1, plus 0 is negative 1. And then the second row, to get a 0 here, all I have to do is take row 3 plus row 2. 0 plus 0 is 0. 0 plus 1 is 1. 1 and negative 1 is 0. Negative 1 and negative 3 is negative 4. 0 plus 2 is 2. And 1 plus 0 is 1. So now when you look at this part right in here, there's your identity on the right. Which tells us the inverse is 3, negative 1, negative 1, negative 4, 2, 1, negative 1, 0, 1. So again, I want to find the inverse of this matrix A here. My first step is to put the matrix here and the identity on that side. I follow Gaussian elimination. I get a 1. I got 2 zeros. I got a 1. I got 2 zeros. I got a 1. I got 2 zeros. And the answer is the matrix over on the right. Okay. So, now we want to solve an equation. My equation is 2x plus y plus z equals 1. Second equation, 3x plus 2y plus z equals 2. 2x plus y plus 2z equals negative 1. My first step is to think of that as a matrix equation. That's matrix A. That's matrix X. And we call this B, which is your answer matrix. This is the coefficient matrix, the variable matrix, the answer matrix. So to solve this, I want to find X, Y, Z. And to do that, all I have to do is figure out what the inverse is, and then multiply by these numbers, 1, 2, negative 1. That's exactly the same thing I did last section. The difference is now I got a 3 by 3. So we need to find that. Now normally I would say, okay, fine. Go off to the side and find it. Except, if you'll notice, what I did on the other page, if you'll notice the numbers I had here, 211, 321, and 212, I already found the inverse on that other example. So all I have to do is take and copy my numbers. It's 3, negative 1, negative 1. So 3, negative 1, negative 1, negative 4, 2, 1, negative 1, 0, 1. All I have to do is multiply these two matrices. Remember, you're going to take rows. Got 3 rows and 1 column. Let me check something real quick. You can't see it, but that was a negative 4. When I put the circle in, I took out the negative sign. Okay, so 3 times 1 is 3. Negative 1 times 2 is negative 2. And negative 1 times negative 1 is 1. So 3 plus negative 2 is 1. 1 plus 1 is 2. Second row, negative 4 times 1 is negative 4. Plus 2 times 2 is 4. And 1 times negative 1 is negative 1. So those cancel out. That's going to be negative 1. When I go to the last one, negative 1 times 1 is negative 1, plus 0 times 2 is 0, plus 1 times negative 1 is negative 1. That's negative 2. So x equals 2, y equals negative 1, z equals negative 2. But the best way to write it is as an order triple, like that. So this is the same inverse method I taught you in 2-4. The only difference is it's a 3 by 3. But once you get the inverse, all you got to do is multiply. Okay, I'm going to end part 1 there, and I'm going to do, in part 2, I'm going to do another example where you got to do the whole thing. That will be coming shortly.